Dear students, today I will discuss with you some important MCQ from the chemical energetic chapter. First question: an ideal gas expands in volume from 1 multiplied 10 to the minus 3 meter cube to 1 multiplied 10 to the minus 2 meter cube at 300 Kelvin against a constant pressure of 1 multiplied 10 to the 5 nm minus 2. The work done is what? Okay, you see question number 1. So your delta V change in volume, your final volume minus initial volume. So what is final volume? Your final volume is 1 multiplied 10 to the power minus 2, 1 multiplied 10 to the power minus 3. So volume change, okay, is equal to 0.009 MQ. Okay. So then what is the work done? Work done is equal to minus P delta V. So this is your P. P is given how much? This much, 1 multiplied 10 to the power 5 and 0.009. Okay. So you will get the answer 900 joule. Okay. So choice your A is the correct answer. Okay. This is your minus because work this expand in volume, therefore it is minus 900 joule. Okay. Next question number, the choice A is the answer. Question number 2: molar heat capacity of water in equilibrium with ice at a constant pressure is how much? See, during the phase change, added heat is used to change the state of the substance rather than its temperature. That means temperature remains constant, delta T remains constant, okay, making the heat capacity. So Cp by dt, here it is infinity. So choice B is the correct answer. Okay. Next, the heat required to raise the temperature of a body by 1 Kelvin is called what? So it is thermal heat and another is specific heat. Okay. So difference between specific heat and thermal heat. Specific heat is the amount to be 1 gram or 1 kg. It is taken. But here 1 Kelvin, that is why it is thermal heat. It is the difference. So here choice B is the correct answer. Next, in a closed insulated container, a liquid is stirred with a paddle to increase the temperature. Which of the following is true? Question number 4. You see, here your work done. Okay. See what is happening here. Question number 4. When it is the adiabatic process. Okay, it is adiabatic process. Adiabatic process. So Q is your 0. Okay, Q is 0. But work is not 0 because some work is to be done. And your internal energy also changes, increases. Okay, therefore delta is not also equal to 0. So you are taking the choice A is the correct answer. Okay. Next, if an endothermic reaction is non-spontaneous at freezing point of water and becomes feasible at its boiling point, then what? So you see, delta H, as it is endothermic reaction, so delta H is your positive. Okay. So delta H is positive. So in B and D, delta is positive. Then comes to delta S, as it is from the your freezing point to boiling point. That means your entropy increases. Therefore delta S is also positive. So choice B is the correct answer. Okay. Next question. The correct relationship between question number 6. The correct relationship between free energy change in a reaction and the corresponding equilibrium constant is what? You see, this is the Sixth question. So we know delta G is equal to delta G 0 plus RT ln Kc. This is the relation. Okay. But here as it is equilibrium state, therefore delta G is 0. If delta G is 0, then delta G 0 plus RT ln Kc is equal to 0. Okay. So your minus delta G0 is equal to RT ln Kc. Okay. So your choice B is the correct answer. Sorry, D is the correct answer. Okay. Minus delta G0 is equal to RT ln Kc. Okay. Next, the molar heat capacity, question number 7. The molar heat capacity of water at constant pressure is this much, 75 joule Kelvin mole inverse. When 1 kilojoule of heat is supplied to 100 gram of water which is free to expand, the increase in temperature of water is what? So question number 7. You see, what is the formula you have to put? So Q is equal to MCP delta T. Okay. What is Q? Q is given 1 kilojoule. So 1 kilojoule you have to convert joule. So that is 1000. Okay. This is molar. So 100 gram of water divided its molecular weight, you will get 5.55 mole. So here it is 5.55. Then Cp is your 75 and you have to find delta T. Okay. So by solving you will get 2.4. Okay. So delta T is equal to 1000 divided 5.55 multiplied 75. You will get 2.4. Okay. This much temperature, this much Kelvin. Okay. Next question number 8. What is the entropy change when 1 mole of ice is converted into water at 0 degree centigrade? The entropy change for the conversion of ice to liquid water is 6 kilojoule per mole inverse at 0 degree centigrade. You see how it is. So we know entropy delta S is equal to Q reversible by T. Okay. So Q reversible also enthalpy change delta H by T you can take. Okay. So this is given, delta H is given how much? 6000. That is 6. What is given? 6 kilojoule means 6000 joule. Okay. Temperature 0 degree centigrade. So 0 plus 273. Okay. 0 plus 273. This is Kelvin. So when you divide, you will get 21.978. That is 21.98. Choice A is the correct answer. Okay. Next, when 1 gram of ammonium nitrate, question number 9. When 1 gram of ammonium nitrate is decomposed in a bomb calorimeter, the temperature of calorimeter increases by 6.12 Kelvin. The heat capacity of the system is 1.23 kilojoule Kelvin inverse. What is the molar heat of decomposition of ammonium nitrate in kilojoule mole inverse? Okay. You see question number. What are the things given? You see Cp is given 1.23. Delta T is given 6 Kelvin. Okay. So Q is equal to MC delta T. Okay. So here this is 1 gram given, and this value C is 1.23, and this is your delta T 6. Okay. This is given 6.12. So by multiplying you will get here 7.5276. Okay. So ammonium nitrate when decomposed, what is molar heat? So for molar heat you have to calculate this molecular mass. Okay. So its molecular mass is 80 gram. Okay, so molar heat, when 1 gram decompose, you will get 7.5276. This much amount heat. When 80 gram decompose, 7.5276 multiplied 80, so you will get 602 something else. Okay, so but you put here positive sign or negative signs because it is decomposition reaction, it is exothermic. Okay, therefore minus sign should be the previous. Okay, so your choice D is the correct answer. Okay students, have a good day.